Okay, so let's do one more supernode problem using an AC circuit. Okay, AC circuit, because here there is a capacitor and inductor and all, right? So therefore everything in terms of complex numbers, right? So here let me mark this. Find the voltage across a capacitor. So this is the only capacitor over here, right? So which means, what is this? This is V1 and this is V2, and since, like I said, there is a voltage source between V1 and V2, that voltage source is 12 angle 30 degrees. So this voltage, since this is a voltage source between this two node, this V1 V2 is a super node equation. It's a super node, right? So here they ask us to find the voltage across a capacitor. This is the only capacitor over here, so which means the voltage across this capacitor is V2 minus 0, right? Or the voltage across the capacitor is V2, right? So that means you should find the value V2. That's the given question. So let's do this question. So here, like I said, this is a super node, which means you are going to mark the currents like this over here, over here, over here, and over here. Okay, these are the currents. So let me write the first equation. So this is basically a current, right? This is basically a current, 2 angle 60 degree, and it is flowing in the opposite direction. So it is, let me write that equation for supernode V1 V2. Okay, so we have, it is minus 2 angle 60, minus 2 angle 60 degree, right? And what about the current through this? It is V1 minus 0 by 1J, right? V1 minus 0 by 1J, that is the current through this branch. And what about the current through this branch? Is V2 minus 0 by 2, right? It is V2 minus 0 by 2 ohms. Okay, and the current through this branch is plus V2 minus 0 by minus 2J, right? 1 2 3 4, 1 2 3 4. So this is equal to 0. This is the equation. So let me simplify this. What is 2 angle 60 degree? Let me see that first. 2 angle 60 degree is 2 shift angle 60 degree is 1 plus root 3J. So this is basically minus 1 minus root 3J. Okay, plus, now I am going to, what is this V1? This is V1, I can write this as 1 by J, right? V1 is nothing but into, I am writing in terms of 1 by J. And what about V2? V2 is basically V2 into 1 by 2, and this is minus 1 by 2J, right? Minus 1 by 2J is equal to 0. Or this can also be written as, this is J into J, so this is minus J, so this is V1 into minus J. And what about this? This is plus V2 into, and this is 1 by 2 is 0.5, and this is also minus 0.5 by J. J into J means it becomes minus, so minus or minus becomes plus. So this is 0.5 plus 0.5J, right? 0.5J is equal to, bring this constants over here, so it will become minus 1 becomes plus 1, and minus root 3J becomes plus root 3J. So this is 1 plus root 3J. This is the first equation, right? This is the first equation. And what about second equation? The second equation is the equation for this voltage source, right? What is this? 12 angle 30 degree. So that means the second equation is V1 minus V2 is equal to 12 angle 30 degrees. What is 12 angle 30 degree? Let me see. 12 shift angle 30 degrees, nothing but 6 root 3 plus 6J. So this is equal to 6 root 3 plus 6J. That is V1 minus V2 is equal to 6 root 3 plus 6J, right? So now this is equation 1. This is equation 2. So since this is a complex numbers, I cannot solve this equation using the calculator, right? So that means I have to use the matrix method. That is representing equations 1 and 2 in matrix form That's the problem with the AC circuit, right? You cannot use a calculator when you want to solve the equations. You have to use the matrix method. So here, let me see, there are only two equations, so therefore only two rows. What is the coefficient of V1? Minus J. What is the coefficient of V2? 0.5 plus 0.5J. 0.5 plus 0.5J. What is the coefficient? Second equation, what is the coefficient of V1? It is 1. What is the coefficient of V2? It is minus 1. Okay. The unknowns are V1 and V2 are the unknown values, is equal to, and what about the constants? Here you have 1 plus root 3J, 1 plus root 3J, and here you have 6 root 3 plus 6J, 6 root 3 plus 6J. Okay, this is it. So here basically the question is to find the value of V2, right? So how do you find the value of V2? V2 is equal to, you replace the second column with this constant, right? So which means when you will find the determinant of first column will be the same, sorry, it's 1, right? First column will be the same and the second column will be the same value, that is 1 plus root 3J and 6 root 3 plus 6J divided by the determinant of the coefficient matrix, and that is minus J 1 0.5 plus 0.5J minus 1, right? So let's find the answer. So therefore V2 is equal to, let me see, minus J into this, right? Minus J into 6, let me see, 6 root 3 plus 6J, 6 root 3 plus 6J, okay, minus 1 plus root 3J, 1 plus root 3J, the whole divided by, what about the denominator? We have minus J into minus 1 is plus J, right? So it is plus J, and here you have minus, this is into 1, so 0.5 plus 0.5J, 0.5 plus 0.5J. So this is basically, to simplify it, I write this as minus 6 root 3J, and this is J into J is minus 1, so minus and minus becomes plus, so this becomes plus 6, and this is minus 1 minus root 3J by, and what about the denominator? You have minus 0.5, this is minus, let me write this again, J minus 0.5 minus 0.5J. So here you have is, let me see, this is 6 minus 1 is 5, right? So first is 5, and this is minus 6 root 3 minus root 3, minus 6 root 3 minus root 3 is minus 7 root 3, so this is minus 7 root 3J by, and this is minus 0.5 over here, and here you have J minus 0.5J, or 1 minus 0.5 is plus 0.5, right? So this is plus 0.5J. This is the answer, which means, let me see, we have is bracket 5 minus 7 root 3J, 5 minus 7 root 3J, that's the numerator, divided by, and the denominator is minus 0.5 plus 0.5J. That's the denominator, right? So you will get this, you will get the answer as, this is equal to minus 17.124 plus 7.124J, or in other words, convert this into polar form, it is 18.547 angle 157.411 degrees volt. This is the answer. Okay, so in other words, voltage across the capacitor, voltage across the capacitor is equal to 18.547 angle 157.411 degrees volt. Okay, this is the final answer. Okay.